Alright, so in the previous lesson we were looking at permutations and combinations, but the thing about those were, for example, we were doing words like friends, and in that word, none of the letters are repeating. Kind of like here in number 1, we have the word math. So if we want to find how many different four-letter words we can make, M-A-T-H, we have all those different possibilities in spot number 1. So we have 4 possibilities there. Take one out, we have 3 in the next one. Take one out, we have 2 in the next one, and so on. So we get 24. Now the thing is, we're going to be looking at words or even options where there are going to be repeats now. So as we take a look at number 2, we're not going to use a word per se, but we have this contest. And in this contest, we have first prize, which is basically earning $10,000, 2 amounts of second prizes, which is $5,000 each, and 3 amounts of third prizes, which is $1,000 each. So when we look at the different ways we can win, in first place, there's only going to be one winner, the $10,000. But in the second place, you can either have one person win $5,000 the first time, and then another person win the second time. But really it makes no difference because second place is second place. Both of them are going to earn $5,000. So in this case, we're going to see a repeat. So when you think about the different ways that we can win, you have first place, since we have a total of 3 third places, 2 second places, that's 5 people so far, plus 1 first place, we have 6 people total that can win. So when we look at our number of ways we can win, in spot number 1, we have 6 different people that can win that option. And then in spot number 2, we have 5 people who can win, 4 people who can win, 3 people who can win, and 2 people who can win, and 1 person. So this is giving us our 6 factorial. But we need to account for the duplicates right here. So because the second place has the duplicate, we need to make sure that person A and then person B winning is really the same thing as person B and then person A winning. So notice here that we're basically going to have to cut our number of people in half because AB will be the same thing as BA. So here, notice what we're doing is we're dividing by 2 factorial. That's kind of showing us our combination that we had seen yesterday. But that's not the only one. We also have the third place winner as well. The third place winner has multiples here. So we can have person A win, person B win, person C win, but really that's the same thing as person C winning, person B winning, and person A winning. Or even that's the same thing as person B winning, A, C, or C, A, B. We have all these different ways. And this is basically showing us that we need to take out all the repeats here, which is going to be 3 factorial since we have 3 winners here. And they can be all done in different orders. Okay, so basically we take our total number of people winning, divided by the repeats in the second place, divided by the repeats in the third place, and if you want, you can even divide it by the winners in the first place, but there are no repeats, so that's just going to be 1. So we just have 6 factorial over 2 factorial times 3 factorial. Let me erase all this, erase this, and erase this. And let's take a look at question B. So now we're saying there's 1 first place winner, 1 second place winner, and 4 third place winners. So again, we look at the total number of ways, which is 6 factorial, and then for the repeats, there's only 1 first place winner, so we can divide it by 1 factorial, 1 second place winner, so that's 1 factorial, and since there's 4 third place winners, we're going to divide it by 4 factorial for our third place winners. So here we have 6 factorial over 4 factorial, and that gives us 30. Let's take a look at an actual word now. So here we have the word mathematics, and we're not just going to use math, we're going to use the entire word mathematics. So when we look at all the different types of letters, we have M, and look at that, we have 1, 2 M's. For A, we have 1, 2 A's. For T, we have 2 T's. For H, we just have 1 H. For E, we have 1 E. We did M, we did A, we did T, so we have 1 I, we have 1 C, and then that should also say you have 1 S. Okay? So basically you find the total number of ways, and in this case we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So we have 11 factorial for our total number of words, divided by, and then we want to take out all of our repeats. The repeats being, we have 2 m's, so divided by 2 factorial. We have 2 a's, so divide that by 2 factorial again. 2 t's, so divide that by 2 factorial again. And all of these are 1, so we're just going to divide 1 factorial, 1 factorial, 1 factorial, 1 factorial, 1 factorial. All those, you know that that's just 1, so we don't even need that. But the main idea here is you have 11 factorial over 2 factorial, 2 factorial, 2 factorial. Do the math, enter that into your calculator, and you get that number, 4,989,600. So basically, in a general sense, if you want to make this into a formula, the number of permutations you have is n factorial, your total number, divided by the number of repeats, the number of elements being repeated. n1 factorial, n sub 2 factorial, n sub 3 factorial, all multiplied on the bottom. So these are the number of permutations of things that are not all different, where you have repetition, things that are being repeated. So the word mathematics has repeats. This is where we use this formula. The word math doesn't have repeats, so we don't need to use that formula. Okay. So let's take a look at example 4 here. Here we just have a grid. I kind of drew all over it already, but we can draw all over it again. The idea here is that a person walks from A to B, then B to C. So here's A, here's B. And then they need to get to C over here. So they're only going south or east. So how can I move? I can go down and then over east. 1, 2, 3, 4, 5, 6. So I can do south, east, 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 east. Or I can do east, south, east, 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 which is, looking at this, you still have 6 E's. You only have 1 S. You can do another way. You can go east, east, south, east, 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 east. So you're still going to have 6 E's, 1 S. So no matter what, however you get from A to B, you're always going to have 6 E's and 1 S. So this is basically showing us that the repeats are the E's, the 6 E's. So how many ways do we have to get from A to B? Well, we have 7 factorial. We know it takes a total of 7 steps no matter what, divided by all the repeats. Well, we have 6 E's and 1 south. So 7 factorial over 6 factorial, that just gives you 7. Now we go from B to C. So to go from B to C, we can go south, east, south, south, south. So south, east, south, south, south means we have 4 S's, 1 E. Or you can go east, south, 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 south. And again, that's going to be 1 E, 4 S's. Whoops, and I forgot this one. There's another east there. So we have 2 E's. 2 E's, 4 S's. So no matter what, you're always going to have this number of S's and this number of E's. So what are the total number of ways? Well, we have 1, 2, 3, 4, 5, 6 moves to do, so that's 6 factorial, over the 4 factorial for repeating the S's, and 2 factorial for repeating the E's. Doing the math there, 6 times 5 times 4, and then what I have down here, you can't really see it, is over 4 factorial, 2 factorial, because right here, 4 factorial, 2 factorial. And I stopped at 4 factorial here because I know that 4 factorials will just cancel out. So you really just have 6 times 5 over 2 times 1, which is 15. Okay, so if we take a look at our total number of ways, well, you have all of these ways, which is 7, and you have all of these ways. And really, you're going to have to multiply these together because it's just like our sandwich and drink problem. You can take one of those routes and take another one of these routes. So you're going to have to multiply them together. 7 times 15 gives you 105 ways. Let's go on to the next page. So here in number 5, we have 12 cafeteria workers. I should zoom this in. Hold on. There we go. We have 12 cafeteria workers. They're rotating among 3 kinds of jobs. Let's say there's dishwashers, servers, and cooks. So with 12 spots, we can leave that open. That's going to give you your total number of ways, 12 factorial. Over, let's do all the repeats. There can be a cook as person A and a cook as person B, or that's the same thing as BA. So we want to take out all our repeats of cooks, take out all our repeats of servers, 7 factorial, and take out all our repeats of dishwashers, so 3 factorial. So just do the math there, 12 times 11 times 10 times 9 times 8, all the way down. I'm going to cancel that out with 7 factorial, since I see that's going to be my largest number. And what I'll have is 3 factorial, 2 factorial. Just enter that into your calculator, and you'll get 7,920.
We'll respect you the most.
Okay, Ben, thank you. Okay, so I'm doing this last one here. So King Arthur had 12 knights. How many different seating arrangements could be made at his round table? So here's our circle, our round table. And King Arthur is up here. We got 12 of his knights all around. It can get complicated, so let's bring it down to simpler terms. If you have 3 people sitting at a round table, we have person A, B, and C, which means we can also have person C, A, and B, or person B, C, and A. Now, if you take a look at these 2 tables, with person A, person B is to the, well, I guess you would say to the right of him. And over here, person B is to the right of him as well. But if you look over here, person B is now to the left of him. So this one is going to be a little bit different. So what we need to do is make sure we account for only the ones that are the same. We want to get rid of, or only the ones that are different. We want to get rid of the ones that are the same. So basically, since we have 3 people, we have 3 factorial, but then we want to get rid of all our repeats. So divide that by 3. So 3 factorial over 3 gives us 2. So if we bring that over to the more complicated case with King Arthur, we have 13 total people. So we have 13 factorial. And then we divide it by, just like over here, we did 3 factorial divided by 3, getting rid of our repeats here. We're going to divide it by 13. So really, this is the same thing as 12 factorial. And 12 factorial is 479,001,600.